Alright, this video is going to show you how to use the CEG interaction curve program. So what you'll see when you open the program is just a bunch of empty fields where you can enter the project number, section name, your name, and the date, and then it asks you to select a section. So under there, you have a few different options. Typical ones would be a wall panel or a column. I'm going to go through both of them, but we'll start with a wall panel. So you select wall panel, you'll see other options will appear: your concrete strength, your heights, and your width, as well as the concrete weights. Here you'll notice a checkbox that says consider all reinforcing fully developed. Typically I leave that checked, so this program is checking the reinforcing you put in as if it was fully developed. Now that means the responsibility is on you as an engineer to make sure that either that reinforcing is fully developed, or in the case of a column, you might provide U-bars at the top to provide some reinforcing that's developed that is different from the main reinforcing. So it's on you, the engineer, to either make sure that reinforcing is developed or check a couple different sections with a couple different reinforcing layouts, depending on where you are in the column, whether that reinforcing is developed or not. Here it asks whether concrete is exposed to earth or weather. Typically I say yes. That's just used for concrete cover calculations. And then down here are a few other options. So right now I'm going to assume we're checking a 8-inch tall by, say, 48-inch wide wall panel. So my height is 8 inches, width is 48 inches. Down here we want ACI 318.02. That's an old code, but the interaction curve calculations are still the same, so we choose 318-02. Now if you want to do pre-stressing steel, click pre-stressing steel tab. It asks you for the number of rows. So let's say input 2, click on go, and it asks for the number of strands and distance from the bottom in inches. So we have an 8-inch thick panel, so I'm going to say 2 inches up from the bottom we have 2 strands, and then 6 inches up from the bottom we have 2 strands. Horizontal spacing doesn't affect the calculation, it only affects the picture that it outputs. Down here, all these numbers you have to input. Initial concrete strength, sustained moment, and relative humidity you can leave as is. Strand ultimate capacity is typically 270. Strand diameter you would pick. For here I'm just going to pick 1/2 inch. And the pull is set by you. So the engineer decides if it's 70 or 75%. And that's all you need to do for a wall panel. And click done. And now my reinforcing is input. The next thing you have to do is input your user-defined points. And these are the points on the interaction curve that you want to check. So typically you want to check the maximum axial load, the maximum bending moment, and a minimum axial load with a maximum moment. So basically that means if at the very top of your beam or your wall or your column you have a point that has, let's say, 2 kips of axial load and 8 kips of moment, that moment might be small compared to the other moments in your wall, but because you have minimum axial force there, you'll want to check that point. So I click user defined points, just say 3 points. Feel free to check more points. I encourage you to check more points until you get a feel for which points are critical and which are not, but at the very minimum you need those 3. So I'm just going to make up some numbers here to check. So you enter the number of points you want to check, and then you enter PU. These are all ultimate forces for axial and bending. These are in kip feet and kips here. So click done. And now that I've input the points to check and the reinforcing, I click generate curve. Now here you'll see this interaction curve pop up. You'll see the diagram, and you'll see the points that you want to check as dots or circles right here. And these are all within the lines of your interaction curve, so you know those points are all okay. Additionally, in this table, it will check the capacity, phi-mn, versus mu, what you input. So you can compare those numbers quickly to see that you're okay. Then you also want to check that these PU numbers are below your maximum PU, which is given as this red line up here. and we're well within that, so we're okay. Input summary, you can click here and it will show you what you input, make sure that looks correct. And code checks, they provide you checks for a minimum steel area, maximum steel area, and average pre-stressing. So these are all code requirements, so it's up to you to determine if you have enough. You can do either minimum area of mild steel, which is one requirement, or you can do minimum pre-stressing. Here we meet minimum pre-stressing, so we're okay. Now let's check another section that would be a column. So in this case we'll do a 24 by 24 inch column. And in this case we're going to do mild steel. So I'm just going to delete all of our pre-stressing rows. And now we want to do mild steel for the column, so click on mild steel. Input's very similar. It asks you how many mild steel rows. I'll say 2. Hit go, and then you're going to put the number of bars, the size of the bar, and where it is located from the bottom. Here you can input, again, the spacing. You can do manual or automatic. I always leave it automatic because it does not affect the capacity. It only affects the display, the printout that shows the section. So now I click done. Again, user-defined points. I'm just going to leave the same points we had before. Click done. Click generate curve. And here you'll see the same thing as before. All your points on here, your check of phi-mn compared to mu, and then your maximum axial number up here. And that's all there is to interaction curve.